Okay, welcome back, stats students. We're going to finish up categorical variables today, and we're going to look at what we call two-way tables. And so two-way tables are very, very helpful, and they're going to actually represent the values of two categorical variables. And these are essential for calculating different types of probability. So we're going to see these a lot in Chapter 5 when we start looking at probability. Like regular tables, these can be frequency or relative frequency tables. And two-way tables, it is okay to switch locations of the variables. So the first thing we're going to talk about is marginal distributions. So marginal distributions allows you to really isolate just one variable and analyze the distribution of that one variable. So to do this, we're going to analyze the frequency or the proportions in the total column for that variable. So we're going to go ahead and look at a situation. We have a sample of 200 children from the UK, ages 9 to 17 were selected to be part of this census at school where they just gather data for all sorts of statistics. The gender of each student was recorded. So our first categorical variable was gender. Oopsie. So gender, along with the superpower they would most likely want to have. So our first variable is gender, our second variable is the superpower. And so we have a two-way table, and what we want to do is calculate the marginal distribution. We're going to do this as a proportion of superpower preferences. So we're going to look at the total for superpower. So we're going to ignore the breakdown between male and female on these superpowers, and we're going to only look at this total for marginal distribution. So to calculate that, what percent or what proportion, because we're doing proportions as the directions say, I'm going to take my total, 30, out of the total number of students, 200. And that's going to allow me to calculate that proportion. And that proportion is about 0.15. And so we're going to keep doing that. So 20 out of 200 is 0.10. 44 out of 200 is about 0.22. 54 out of 200 is 0.27. And then 52 is 0.26. So now we're going to go ahead and draw the bar graph for that. And so we did these as proportions, so I'm going to label this side as proportion. So that way everyone knows what I'm talking about. And I'm going to go ahead. Our highest proportion is 0.27, so I'm going to leave myself lots of space. 0.1, 0.2, 0.3, 0.4. So I don't have to go up to 100%, but I do have to start at 0. And so now we're going to go ahead and do invisibility, super strength. And so you have the ability where you could kind of write sideways invisibility, but if you wanted to, you could also say I stands for invisibility and write yourself a key. So if it makes it easier on you to keep your graph looking nice, that's fine. But you have to have the key there. You can't just assume that people know that SS stands for super strength. And so on and so forth. So for our instance purposes, I'm going to go ahead and I, SS, T, F, and FT for us. And then I'm also going to go ahead and make them different colors so it's a little bit easier. So here's my I, which was about 15%. So I draw my bar. And now since I made it one width, everything else has to be that same width. So I'm going to go to my super strength, and it's 10%, or 0.1 as a proportion. And then I'm going to go to telepathy, which is 22.22. And then I'm going to go to fly, which is 0.27. And then I'm going to go to freeze time, which is 0.26. And so this is really just like what we were doing, but it's taking the original two-way table and only isolating the one thing that we want. So the next thing we're going to talk about is the conditional distribution. And so conditional distributions follow closely to our conditional probability. So again, we'll be seeing this in chapter 5. And with conditional distributions, we look at one category for a variable. We break it down, like males. So we look at just the one category within that variable and analyze the distribution of the second variable. So we're going to look at the responses of superpowers just for males. And then we'll look at the responses of superpowers just for females. So then we can compare between the genders. And so the way that this is going to end up getting worded is find the conditional distribution of our top variable. So this is going to go on the top of our fraction among the total for our second variable, which will be the bottom of the fraction. It'll make more sense when you see the problem. And our bar graphs for conditional distributions are what we call a side-by-side bar graph. So it allows us to analyze the differences between those categories. Okay, so we're going to go ahead and we're going to calculate the conditional distribution of responses for each gender. So when I'm looking at this, I'm going to have my responses on top and the total for the gender at the bottom. So we're going to go ahead and look at females first because that's my first category. So I'm going to take my invisibility and I'm going to divide by the total number of females. I'm going to take my super strength and I'm going to divide by the total number of females. And so on and so forth. And so that's going to give me that conditional response for females. And then I'll do a conditional response for superhero powers for males. So for males, it would look like 13 out of 85. Keep in mind, look, this is a different total. We have a different total number of males. 17 out of 85. So on and so forth. So I'm going to kind of make a little table over here that actually tells us what those proportions are. So we start off with 0.15, 0.03, 0.34, 0.32, and 0.17. So now I'm going to move over to a male, so I'm going to use that same male's color. 0.15, 0.20, 0.06, 0.21, and 0.38. Now, from here, we're going to go ahead and do our side-by-side bar graph. Now, it is up to us kind of how we set this up, but if I'm trying to look at the differences between gender, the two bars I want side by side are the genders, not the superhero properties. If I wanted to analyze superhero properties for each superhero, then I'd have the superhero properties side by side, not the gender. So when I'm looking at this, I'm going to do the same thing as last time. We're going to have proportion. we're going to do that same scale as last time. 0.1, 0.2, 0.3, 0.4. I'm going to use the same labeling as I did last time. Invisibility, super strength, telepathy, fly, and freeze time. So now when I'm breaking this down, I'm going to go ahead and look at it like this. So I'm going to go ahead and do green. Let's see. This is my invisibility. And my green is going to be my females. So 15% for females. And then I'm going to go to purple for my males. So 0.15. So they're pretty equal for invisibility between the two genders. So then I would move on to my next category, which is super strength. And so I would look at, for super strength, 303.03 for females, and then 0.20 for males. Big difference. Big difference between those. And so then I'd move on to the next one. So we have telepathy. So I'd go to females, 0.34. And then 0.06. And so I keep on going. Fly, freeze time. So for fly, we had 0.32. Oops. And then 0.21. .17. And 0.38. So there you can really look at those differences of genders for each one. And so then when we're looking at this, based on the survey data, can we conclude that boys and girls differ in their preference of superpower, give appropriate evidence? So I'd look at this and I'd say, holy cow, there are huge differences between almost all the categories except for one. So I'd say yes. Only one category, and what category was that? Invisibility. Had the same or close in same. It should be similar. That would make that sound much better. Had similar or close in values between genders. And then you could even go into more detail saying that all the others had at least a difference. Let's see, we had a difference of 17, a difference of 28, a difference of 11, a difference of 21. So all of them had a difference of at least 10%, which really shows that there is a big difference. All of them had a difference of at least 10% or 0.1, a proportion of 0.1. So there's only one that really showed that there was similarity. So I'd say there's definitely a difference. And we're going to learn mathematically how to tell, is there really a difference or did this just happen by chance? And so we're going to talk about that as we get farther and farther. Okay, the last thing is a segmented bar graph. A segmented bar graph are not on the AP exam. And they're kind of like pie charts. They're really popular in media, and they can be done several ways. It can look like, okay, here's my females, 100% of my females, and then show how all the different things are broken down. So with females, we had 15% for invisibility. We had 3% for this, and then just kind of break up that 100%. And then over here we do the same thing for males. The problem is it's really hard to compare these, because in males we'd get that 15%, but then we had like a 20%. And so then it's hard to compare this box to this box down here, because they don't really line up very well. And so it kind of plays tricks in our eyes and makes us think that there's not big differences when there are. Or it may exaggerate those differences. Okay, so we're done with categorical data, and then we're going to spend the rest of our chapter on quantitative data, because there's so much to it. There's so many options.